Right. Introduction to the soil science. Anyway, so naturally we are dealing with, we are one of the part in earth science. So very first we want to know how our mother earth was formed, how our earth was formed, how the earth was formed. Naturally, students, different kinds of theorems. What kind of theorems? There are few theories are there. Do you know what are the two major theories which explains how the earth was formed? It is only theorem, it is theorem, it is assumption only. Whether it is real or not, it's different issue, but it's only assumptions. There are two kind of theorems are there. What are those? We will see this one, evolution of earth. Very first we want to know how the earth was formed, our mother earth was, how the earth was formed. Very first, students, origin of earth completely explained by the two theorems. What are those? One is planetesimal hypothesis, this is one hypothesis, and another one is nebular hypothesis. These are the two hypotheses natural regularly we follow, and these are the major two hypotheses which explain how the earth was formed. How the earth was formed, these are the things we want to know, how the earth was formed. So very first we will see this. This is a planetesimal hypothesis. Actually, this term is nothing but, well, maybe there is one kind of small theorem. What will happen? Some big star may have one big star, or whatever might be. Some kind of star was came into very close to the sun, and what happened? All of us completely was blasted. That means theorem means it is moved away. So what will happen? Those blasted matter, those tear of matter, what happened? That matter was condensed and started to move around the sun in the form of orbits like this, students. First it was teared away, sorry, yeah, it was teared away, and some disk like all the sun orbiters was formed, and that was what will happen. These are called, these orbits are called planetary nucleotides. These are called, this form of is called planetary nucleotides. So that's, this theory was explained like this. So part of the complete ball was completely was bursted. So that was that state of matter was what happened, condensed and form orbits around the sun. So what happened later on? Those were converted as planetary nucleoids. Like this, they finally by this theorem. What next? Nebular theorem. What nebular theorem is? Is it audible, students?
Yes, sir.
Then wait. From where we missed? From which part we have missed? I mean, I have missed. Students, please, you should say from where I have
Ne-
missed.
Nebular theorem.
Oh, we are in nebular theorem. Okay, fine.
Yes, sir.
Yeah, yeah. So nebula, or this cloudy mass is called nebula. So what he said, it was very, and later the cloudy mass was become very hot and incandescent. It was perpendicular. It was in a perpendicular motion. It was completely in a, it converted into perpendicular motion like this. See, they follow this diagram, students. What is completely move to a perpendicular. What happens slowly? That hot mass, that hot nebula, what happened? Completely cools and vapors in the form of rings. So what happened? Slowly, this hot nebula. Sorry, this hot nebula, what happened? Slowly was condensed. What happened? Further condensed and distributed in the form of, in the layer. What happened? This condensed nebula, what happened? In circular motion was cooled. The nebula was becoming cool and vapors in the outer layer and condensed and throw it in the form of rings. This hot nebula slowly become condensed and cooled, and it is formed in the form of rings. So further condensation. So slowly, what happened? Further, what happened? That is completely cooled down, and that leads to the formation of our present solar system. All our nebula are completely formed, helped in the help leads to the formation of planets. So what is nebula saying? Very first, the nebula was very hot vapors are there. That cloudy formation. What happened later? It was due to the cooling nature. This hot nature was completely decreased and become very cool due to this perpendicular motion. What happened again? That was again day by day, years after years, it was completely cooled, and finally we reached here. Even though, but in early stage, the sun also is somewhat condensed, somewhat not that much, not to what this theorem is saying. The sun also is somewhat, the central mass is still incandescent, not yet considered sun in the early days of the formation of the solar system. So later on, what happened? Finally, some rings were formed. That rings were in that ring place area. Today, what we so-called planets have been formed. This is what the nebular hypothesis was completely explained. Nebula Nebular theorem was somewhat very interesting and somewhat very easy to understand compared to the previous theorem, just like the blast, all those things. And there are different names and different kinds of things. There are many theorems are there, but we are not going to touch all those things because we are soil scientists, not geologists or earth different kind of people. Our interest is only soil. Now we will come back to our earth. What is earth conditions are there? What kind of earth systems are there? We will see all those things, students. Right, students, earth. Now, it's a very fundamental, students. So this is very elementary, very primitive for all you of you know that what different kinds of spheres, lithosphere, the very solid part of earth, and atmosphere, the very gaseous part where completely gases and conditions are there, air conditions are there. Another one is called hydrosphere. These are completely water conditions. The water condition was prevailing, and the water covered area is called hydrosphere. And biosphere bio means life, the life conditions where the life was prevailed on the earth, it is called biosphere. So majorly we will see this type of things, students. This may for your mind may think, oh, it is very fundamental, very elementary, why we have to discuss, but it is better to discuss fundamentals in every time to be strong in very advanced times. Okay, lithosphere, which is solid part, earth conditions, atmosphere, which is gaseous part, and hydrosphere is nothing but water part area. And another one is called biosphere. We'll see the biosphere. Now we will discuss about something about these spheres, and the coming slides are very important for you. Please note it down, some important points in the coming slide. Vast. Now earth is speaking. These are my atmosphere compositions. Our earth is speaking. What are those? This is what atmosphere, students. Naturally in atmosphere you can see nitrogen content was very high, around 78%. We can see, and oxygen was 20.9 percentage, somewhat less, somewhat no, second largest. And later on we can see organ gases at 0.90% are there, and other gases less. What are the left out gases are the noble gas, etc. All comes under 0.17%. And carbon dioxide is naturally 0.03 percentage, but nowadays there is some fluctuation is there. You can see some area, some literatures are citing it is more than 0.03 percentage. That's a different issue. That's comes under pollution, all those things. Anyhow, in general, in nutshell, these are the conditions of the prevailing atmosphere gaseous conditions. Students, you may wonder, in very olden days of ICAR examination, they have asked this composition also in examination, content of oxygen, content of nitrogen. And now one question to you, students. We have this much nitrogen atmosphere, right? I think all are listening to me. Students, we have this much nitrogen, 78% nitrogen is there. Then why, sir, we are adding nitrogen, we are adding urea, we are adding different substances? Why? What is the reason? Can anybody give answer? Very fundamental question, students, because it's a very fundamental class. Why? We have 78% of nitrogen is there in air. Then what is the need of giving urea in the form of fertilizer? Why we have to give nitrogen to the soil, or not soil, to the plant? Why? Please
Plant
answer,
cannot take direct.
students.
Plant can. Plant cannot take elemental nitrogen, no, sir. They will take in nitrate or nit.
Yeah, plant cannot take the elemental form of nitrogen form. That's why it
Yes.
needs
Yes.
some conversions. Only our MSc graduate is saying answers. What about us all? Miss Rai and Ramya, all of you, please, thoda answer dijiye. Right? That's the reason, though we have that much of nitrogen also, we need some conversions. Plant cannot use that elemental form of nitrogen, so that is very difficult for them. That's why we need some microorganisms, that is called the transformation, etc. We will read in the chemistry all about all those things. So this is the composition of atmosphere, students. And coming to the next one, very interesting. So overall, students, overall weightage, weight was around 1
Sir, your voice is not clear.
atmosphere consists of weight was very less. It's around 0.03% of weight comes by the atmosphere only. Very less. Okay, students, here there is some newer cyclone is it? That's why my signals are too worse today. Anyhow, I think here I have lost the connection. 1 minute, students. I have to check.
Hello.
Okay, this is what I'm saying. So these are the layers. Earth was audible to everyone. Hope it is audible.
Yes, sir. Yes, sir.
Anyhow, okay, is it now it is audible?
Yes, sir.
Is it audible?
Yes, sir.
Yeah,
Now
there
it is
are
audible.
questions from these part of area, especially students, even SRF students also. This is very fundamental. There is no there is no division of SRF. Yeah. Thank you very much, students. Anyhow, you can see this variation, students. See, the layers: troposphere, very first layer is troposphere, and stratosphere, mesosphere, thermosphere, and exosphere. And we should know the how much distance it was covered. Please note it down, students. Today itself, now itself, you please note down the key points from today, from this lecture 1 to you have to please maintain one small pocket note regarding with these key points. Okay, students. Troposphere, it was extended from 0 to 12 to 18 kilometers. Here we can see the flying of hot air balloons, passenger planes, etc. We can see troposphere. This was from how much it was extended from around. It will from Earth's surface to it was reached up to the 18 kilometers, 12 to 18 kilometers it will be. And atmosphere, it is around 11 to 15 kilometers, 50 kilometers. It is extend up to 11 to 50 kilometers. That is called the stratosphere. Here we can see some radios. I mean, one is know about this kind of balloon things were used. So anyhow, to yeah, students. Now coming to the mesosphere, it was extended up to the
What is going on?
40 to 50. I mean, here some around 50 to you can expect up to 90 kilometers. This mesosphere, we can see here it is meteoroids and all those things. Okay, students, this is regarding the mesosphere. And coming to the next one, please note down this height. This thing, this student. This is very important for your examination point of view. This is very key for your examination. Okay. And another one is called thermos. The temperatures also has been given here on 12,000 centigrade, 80 to, you can expect some thermosphere kilometers, 8,000 to even extend up to the atmosphere. In exosphere, you can see our spaceships. This is what about the layers, and coming to these are the temperatures. In exosphere, 1200 degrees Celsius it will be there. Here you can see around meso, you can see around 86 degrees Celsius highest, you can see maximum in strato, you can see 25 degrees Celsius. So I mean minus 2 to, and around you can here you can minus, you can, it will be in minus degrees Celsius, students. From minus 225 to 2.52 to 2.52 or to 86.5 degrees Celsius to be there. But here we can see from minus to, we can see here 1200 degrees Celsius. Here we can see 50 own in our area. What we are located, what we are living, it is around the 15 to minus 56 degrees Celsius. That's why, students, whenever you can see any, you can see any mountaineers or whoever that climb the Mount Everest, everything, you can see the temperatures will be very goes on decreasing, but all of a sudden if you reach to the thermosphere or an exosphere, the temperatures will be increases. This is the reason we can see. And also the content of oxygen is very less if we go to the very high altitudes. That's why it is very difficult to take breath, and that's why we have to carry the oxygen cylinders and all those things. Anyhow, students, for examination point of view, you have to note down all these points, all these kilometers, how much stretch was climate was stretched, everything. And also you have to note it down this temperatures, all this minus degree Celsius and 15 degrees Celsius. So these are the layers in atmosphere. These are the different forms of layers in atmosphere. You have to know this, very important regarding the examination point of view. This slide is very important. Please note down these values and these temperatures and this height and what are the things of atmosphere. And you have to know what are the things used to take place. Naturally, here you can see some aura, means some deflections of light, all those things. You can see meteoroids here in meso, and here some gas balloons we can see. Here you can see some hot air balloons in troposphere, and even helicopter, sorry, our flight planes will be right here. These are the things regarding the layers of atmosphere. If you go to the next layer, next chapter, that is next thing of sphere is called hydrosphere. hydrosphere. See, students, around covers almost 3/4 of the Earth crust is completely covered with water. We can say only water. The hydrosphere is 10 kilometers, 70% of Earth's sphere, and it makes around, take the entire Earth mass. In Earth mass, it's consisting of 6.91 percentage. We can see Earth mass. Students, please note down these values. Some these values. You may think these are very small issues, but these small issues will cost many things in your examination. So it contains about some absorbed gases. We can see some absorbed gases. We can see, and we can see some rocks with sediments. We can see, and mostly this water where we can see mostly in rivers, ocean bases, lakes, even in groundwaters also we can see. The quality of water completely varies, students. The quality of water completely varies from place to place, area to area. You know all those things, and especially in problematic soils, we will learn the quality of water and what kind of what is the use, what kind of water we have to use for agriculture and drinking purpose. We will deal in very further classes, students. Anyhow, these are the things about the hydrosphere, students. Almost everyone knows it's completely covered with water. And coming to the next, students, what are the just now I mentioned one point, the quality of different waters. Actually, there is in English there is no word called waters, only water. So there are different kind of water varies from here. We can see what are those. You can say around in groundwater, in overall water percentage, if you take, the share of groundwater is 30.1% only, and the water which is kept in the ice caps and glaciers, you can see around 68.79 percentage, right, students? At the same time, in lakes, 87 points. In swamps, that means some marshy area swamps, all those things, you can see 11 percentage. In river, you can see 2 percentage. But majority is only saline water, students. If you took overall water, it is saline water, 97 percentage. In that, only 3% only fresh water is available. In that 3%, we can see only 31% we can see in fresh water in the groundwater. The fresh water is 3.3% only, 30.1% comes under groundwater. In ice caps, we can see 68.7 percentage. We can see in ice cap that fresh water was hindered. And you can see in lakes, we can see 87 percentage majority. You can see here. And swamps, we can see 11 percentage. In rivers, we can see 2 percentage. In surface water is around 0.3 percentage. So overall, students, you want to know most of the fresh water is completely comes from our lakes only. Lakes we get most, and the second share it goes to the groundwater, which is in ice caps. Though it is ice caps, we have 68 percentage, but we can't use this. It is very difficult to use. Though its a major share is around 67.7 share is there. This is regarding with the what is the quality of water, what kind of water we are using daily. So only this entire population was completely depending upon this small bit. Small one bit is called the 3% of fresh water. And next we can see, students, lithosphere. Lithosphere, it is a solid part. The solid sphere, what we are today, where we are thriving or where we are living, it is nothing but it is called the lithosphere. So in lithosphere, you can see ocean bases, plains, plateaus, mountains, valleys, and sand dunes, lava, etc. Everything we can see. And how much mass it carries? It carries around 93.06% students. So note it down, students. How much part of atmosphere mass was carried by the Earth is atmosphere? How much percentage was comes under the our hydrosphere? And now here our lithosphere is 93.06 percentage. So these are the key points, and that are layers of atmosphere and this quality of water. So these are the important points you have to remember for today's class. For today's class, the interior Earth consists of, in interior, if you go very interior, we can see some rocks, some minerals, even we can see some gaseous, some water envelopes. Just like that, water envelope is nothing but groundwater. We can see all those things. We can see, even we can see some of our valuable mines, coal, all these things, petroleum, etc. we can see in this lithosphere. So what are the layers, sir? In lithosphere also there is some layers. So before going that layer, what are those layers? Anybody have idea? Students, do you have any idea regarding what are the layers in our solid part in Earth?
Mantle and core.
Yes, Abhishek, you please speak. It's not clear.
Crust, mantle, and core.
Crust, mantle, and core. This is what we are going to deal in the next slide. Yes, this is what this Earth is saying. These are my layers. So Earth was speaking to us. So we can see just now, we can see crust, mantle, and core. In core, we can see outer core, inner core. and this anthenosphere. Students, if you want to study detailed about this crust, mantle, and core, that will be a different part. But we'll see only the names and how much area was distributed. Crust you can see up to 100 kilometers thickness you can see, and mantle around 2,900 kilometers you can see, and core overall core you can see around overall from 5,100 you can say from here to from 2000 to 500 100 kilometers, and from 5,000 if we go very deep overall you can see around 6,378 kilometers. So this is the crust, mantle, and core. These are the different layers of it. In mantle we can see atmosphere, there is somewhat liquidy layer. It's a different issue, student, just keep the name. So like this we can see some in the different place, and mostly our interest will comes only up to this crust, because here in this part we can see many mountains, our regular activities we can see. So these are the things in this slide. We have to remember these numbers: how much area was crust was going on, how much area was mantle, how much area for outer core, and how much area for inner core. So you have to note it down these points. Please, these numericals are very important. Probably anyone can say crust, mantle, and core. But suddenly, if in examination you ask how much kilometers, how much thickness, or how much kilometers we have to go for see the mantle, means then we will be in trouble. So please note down these numbers: 2,900 kilometers, 5,100 kilometers, 6,300 kilometers. Naturally, crust, everyone can remember crust because very small one, 0 to 100 kilometers. So these are the different layers in lithosphere. So these are the important, students. So regarding with Earth was introduction to the Earth was this is what I want intended to say. So these are the important points regarding with the Earth evolution. And now we will see the composition of Earth. So Earth composition, students, you can see naturally Earth has hardly, we can see Earth means contains, what is it? We will see only rock. For our eyes, we see only rocks, some stones and pebbles. That is what our regularly we see in our day-to-day life. We will see Earth means some rocks, pebbles, mountains, etc. Hardly whatever. All of a sudden, if we talk about Earth means naturally in our mind, what it will we strike. It will strike only. We say, oh, Earth means, so it's nothing but some rocks and stones. That's what no. And also with the rocks, there are some elements. Here I'm mentioning 106, but nowadays it's crossed many new elements, new man-made elements was included. There are more than 106, I think more than 110 is there. So many elements are there, sufficiently abundant, constituting of 98.6 percentage of the Earth crust up to 16 kilometers. So in Earth crust itself, you can see all these compositions, all these minerals. So out of these, students, out of this great abundance, out of the 8 elements, only 8 elements are the out of 8 elements, 2 are great abundant and comprising of 3 by 4th of total composition of crust. Actually, the other 6 elements are metals. So these are the 6 elements. Some are metals. So some non-metallic elements are oxygen, silicon, titanium, hydrogen, carbon, and metallic elements are something like aluminium, iron, our calcium, sodium, potassium, phosphorus, chromium, barium, magnesium, all these things. And we can see some percentage of magnesium also. I think next slide you can understand very clear. So this is the composition, students. These are the compositions of oxygen. So naturally in soil or in earth, you can see whether it's soil or earth, natural soil, earth, oxygen is highly available, students. Available around 46% you can see. And next you can see silicon around 27.7% was second available element, silicon. I think in very old exams they used to ask these questions. Element available in the soil or earth crust. They may ask in earth crust and all those things. So this is called the oxygen and silica. And later you can see some magnesium we can say availability is there, and later on iron we can say around 50% is there, and calcium is 3.6% is there, and sodium is 2.8 percentage, 2.6 is potassium. But naturally Indians are also rich in potassium. So naturally, and magnesium is 2.1 percentage, and later on other elements, all other tracer elements or micronutrients considered are 1.5 percentage, a very less quantity. So these are the net composition, these are the basic composition of our earth crust, students. And next we will see soil. Finally we came to the soil. So up to now we have seen the up to here we have gone through very introduction to the only earth conditions only. This is enough for a soil scientist. This is quite enough, because we want to deal about very in detailed about those crust, mantle, atmosphere means we have to leave our main core subject. So that's why we have to know some fundamentals. So these are the very rarest and rare fundamentals, students. So students, if you have any questions regarding my previous slides, you can ask me now, and later we can continue this soil. Any questions regarding with previous slides, students?
No, sir.
Yes, Sweta?
No, sir. No doubts in previous slides.
Your voice was
No,
not clear. Your
no
voice
doubts,
was
sir.
not clear.
No doubts.
Oh, no doubt. Okay. Thank you, students. I think probably this is very fundamentals. That's why you may not, I may not expect any questions from here. There's a very, but very fundamental. If you neglect it means you have to pay many, because small things will lead to big damages in examinations, because you're preparing for competitive exams, not semester exams. Anyhow, definition of this soil. Very first, students, soil. Actually, soil was derived from a Latin word. It's coming from Latin word and it's given definitions are there. But overall, I took only two definitions given by the great people like Ducky Chow in 1900 and Jenny. Both are very core band members. One person is given a great, one consider, even Ducky Chow is considered as a father of soil science, and Jenny is a great person who given the soil forming factors. Actually, in pronunciation we should say any, not Jenny, any. Anyhow, what Ducky Chow definition? Tokigawa said, soil is a natural body composition of inorganic and organic constituents having definite genesis and distinct nature in its own. So, what Dukichev is saying, soil consisting of both organic and inorganic components, which have definite genesis and distinct nature. For this one point, definite genesis and distinct nature, Dukichev was considered as the father of soil science. He is only for giving this one thing, genesis and distinct nature. That's why he was considered as the father of soil science, or even actually, if you very deep you want to go, was considered as a pedologist, very famous pedologist. And what Jenny is saying, sorry, Annie is saying in 1941, soil is a naturally occurring body that have been evolved owing to its combined influence of climate and other organisms acting on the parent material and conditioned by the relief over the period of time. See, Jenny was a great scientist. He given his own, he showed his influence here also. See, he talked about the parent material, he talked about the climate, he talked about the organisms, and he said it's a naturally occurring body. That is the greatness in Jenny's definition. And he talked about the relief. See, he given all the soil forming factors. Soil is a naturally occurring body that have been evolved on to combined influence. He said it's a not a single factor, it is a combined influence of climate, organisms means our biological factors acting on parent material. These all things were acting on parent material. So parent material also contributing something to the soil and as conditioned by the relief over a period of time. So he given a very, he gave a period of time. See, both the definitions are very good, but Jenny definition was completely explaining the, or giving a clear cut explanation about the how the soil was forming, what are the important things was happening in the soil, was given by the our great man called Eni. But Dokicha was also one of the great person without any technology. He given this definition. So both are great definitions are there. So probably students, why I'm giving more importance on definition means this if you understand this definition, definitely you will have some tempo. You can maintain the tempo in soil science. Anyhow, we will see in the next slide what are the concepts. So naturally in soil science we can see there are a lot of concepts have been evolved. We can see naturally how we can get the knowledge on soil, students. How we can get, what are the reason, how can we get the knowledge on soils? One thing, either you should be a farmer, you should have a farmer, and you should cultivate the crops, then automatically you can understand what is the condition of the soil, how to manage the soil, how to maintain the farm. Or or be like us, like we agriculturists or soil scientists, we know how to maintain the soil conditions. So these are the two experiences we can see. And later on, but in very olden days in Chinese itself, they have drawn these thematic maps of soil maps based on the taxation. So for taxation purpose, for collecting income, Chinese people, what they did, they have drawn some soil maps to collect these taxations. You will read this very interesting topic. It is actually taxonomy. You will read in further classes. And Homer referred the used the manure on this. So this is the only first person 1000 BC before Christ. He used the manure on the land. So he applied the manures to the plant. And early Greek and Roman writers scientific farming systems have been given law involve the leguminous plants use of ashes and sulfur as a soil supplies actually. So early days, early olden Greek Roman civilizations also we can see apply you can use of legumes or you can use the application of sulfur especially. Actually the sulfur is a agricultural product, but later what happened, the same sulfur was used in the wars also, and also they have applied in the agriculture and the soil conditions. So these are the some concepts which later on was developed from they developed, and today our present generation what we are doing, the Greeks and Romans, these are olden history, but today what we are doing for soil. Any ideas, students? What are the growing subjects in soil science nowadays? What are the growing fields, especially the PG students? You should say, what are the growing field in soil science now? Come on, this is only introduction class.
Remote,
Yes,
sir,
yes,
remote sensing is now growing now.
yes,
One
yes.
of the major.
Yeah, the same subject I'm doing research, remote sensing. Remote sensing is a present very trendy subject. Another
GIS,
one?
yes, sir.
Yeah, GS,
Another,
GPS. That is one
yes.
thing. And another one?
Sir, organic farming, we can say.
ये सही है organic farming. Okay, organic farming was comes under different. Okay, organic farming, but in soil science, particularly in soil science.
Yes, sir.
Nanotechnology. Have anybody heard?
Yeah, yes,
Yes,
sir,
sir, yes, sir.
nanotechnology.
Yes, these are the growing scientists. Students, you're all young minds. You're all come. You're probably the students of MSc. Some PG students are there. After completing, you definitely will get a very good score in PhD entrance. You will become SRF. Please go through modern techniques only, but also read the old techniques also. That is also very important because modern techniques are completely dependent upon the old techniques only. So old is always gold. But remember one thing, gold is never is a old. It's a very probably very interesting line recently I have heard. So remember that thing. So learn the old methods and also maintain that good knowledge on new technologies also. So go ahead like that anyhow. And coming to the class, students. So today we are developed many things. We are drawing maps. We are going for site specific management. We are giving proper importance to the soil. We are going for soil testing. So a lot of the things were changed a lot, especially students when we were in BSc and now we are in PhD. These 10 or 8 years, many things was came in soil science, many things in academics, and many things was came, lot of drastic changes are there. So according to that change we have to plan. Anyhow, students, coming to the class, we'll see in the next slide early investigations. So early scientific investigations. What early investigation? Bossengalt, JB Bossengalt. Please remember the scientist student, just you write in your paper. Okay, students. Anyway, so Bossingall, please take a paper and note down JB Bossingall proved that air, water were primary source of carbon, hydrogen, oxygen. Just you now itself you note down. You note down now itself. Definitely it will be very easy because these fundamentals you may not revise in very hurriedly. You should not go in very end of your exam. Anyway, coming to German chemist Justin van Lieberg, what he said, crop yields were increased by adding, he said crop yield was increasing by adding minerals and inorganic elements of soil, and he proposed the mineral elements in the soil and added manures. This is a person, and also disproved the humus theory. You will read this humus theory in chemistry. So in humus theory he disproved the humus theory. Another one person is called Lieberg. You may, if all are you from BSc and masters, he proposed the law of minimum. He said one single factor is depleting is definitely there will be some problem. He explained the Liebach was given the law of minimum, and R. Warrington, he is a one person. He given he explained about the nitrogen transformation or biological. He is the first person, and another one is called yes, Vinogradski. In 1890, isolated two group of bacteria responsible for the nitrogen transformation and nitrogen assimilation bacteria growing in nodules of the legumes. So Vinogradski, especially in microbiology, you may heard this person very famously, very popular. This person is very popular. He is the person who had given the bacteria was transformed by nitrogen transformation. He given the two isolation group and also he explained that bacteria was growing in the nodules of the legumes of the plant. So remember the scientific words, students. Please now itself, you please note down in your paper or you note down in your running notes about these scientists. Now itself, don't be postponed. Coming to the next, students, branches of soil science. So I will say one branch. You should, students, you should speak what are those. Okay, very first branch, pedology. What is the meaning of pedology?
Soil forming factors.
What is the meaning of pedology, students?
Sir,
Soil
soil
forming.
genesis, classification, mapping.
You do in pedology?
Sir, soil genesis, classification, mapping, we can say. Hello.
Students,
Hello.
students, please. Is it audible to everyone?
Yes, sir.
Which one? Right.
Hello.
Okay. Students, one person is said pedology. Yeah. Pedology is, he said pedology is soil forming factors. We will read all those things. Very good, students. Another one is adapology. What is the meaning of adapology? What is the meaning of adapology, students? What is the meaning of adapology? Please say.
Study of soil in relation to plant growth.
Please, students, what is the meaning of adapology?
Study of soil in relation to plant growth.
My God, it is too bad.
Hello.
Yeah, we will read about this. Adapology means we'll read the soil related to the plant growth and all those things. Okay, students. Soil fertility. Yeah, that's fertility. We will read about the fertility status, all those things. Swati, you please quiet because you are a PhD graduate. You are answering everything. These are small things. Yeah. Yeah, please. Yes, yes. Mr. I'm unable to hear you.
Sir, it's not audible. What say? Hello.
Oh, lot of disturbance. Stuck on. Right, students. Another part is called soil microbiology. Microbiology means we will read about all kind of microbes, everything in soil. And another kind is there, that is called soil conservation. That is a different thing. Soil conservation means just reading. We will read about some problematic conditions, erosion, all the conditions of pH, salinity, etc. We'll read about all those things in soil conservation. So before moving to the next slide, can anyone say what is the analysis is this? In physics, I'm showing my cursor is moving here. Can anybody say what is this analysis in soil physics? Please, students, can anybody say what is
Particle size analysis.
Hello. Please, anyone? Is it audible to everyone?
So no, sir, voice is not audible.
Is it audible now, students? Really, the
Yes.
climate here is very difficult for me because there is a
Yes, sir, it's audible.
my signals are very bad here. Signals are very bad today in my area. Thank you very much, students, and very thankful for your patience. You're still in the class. So these are the branches. Anyhow, if you say what is this analysis, then we will continue. What is this analysis? The soil physics. I'm showing this slide. What is this analysis? What is the name of this analysis? Can anyone answer? Can anyone answer? What is this analysis? Students? Students, is it answer? Hello?
Vinay is not present.
Hello?
Article size analysis.
Oof, this is not fair on my part. Anyhow, students, I don't want to waste the time. So this is regarding with the branches of soil science. At present, students, for further coming classes, you will read about this branch, pedology. You're going to read about, I'm going to take about all the classes about regarding with pedology. Pedology means you will see taxonomy, classification of taxonomy and soil formation, genesis, and soil survey, etc. Everything will be dealt by in this pathology, in this pedology. So we will, so further class, from next class onwards, we are concentrating on this pedology only, and later on we will jump to the fertility. After completing fertility, again we will go through chemistry like that, and later on we go to physics like that. We will go in a very step by step manner. Okay. Anyhow, student, these are the branches of soil science. So hardly no one is giving answer for me. What kind of analysis is this? Students,
Article size analysis.
you don't know what kind of analysis is this in.
Article size analysis.
Abhishek.
Yeah, no, I think one student have gone. Anyhow, students, try to understand. The climate is not good here. Right, this is the composition of air, components of soil strengths. If you see, in soil you can see total you can see 50% of um, in 50% is mineral matter, 5% is organic percent air totally. So this is what in matter totally in solid percentage, 50% is mineral matter. In that minerals, in mineral matter, and 5% is organic matter only. In another 50% is around 25% is air and 25% is water. We are going to deal all these things separately in separate lectures. Okay, student. For this is only for introduction. This is regarding with soil components. And coming to the next, mineral matter. In mineral matter, students, please note down, students, please take your note and please note down these things. Please note, if your rock fragments are 75 mm or 20 centimeters, it is comes under the gravel or pebbles. Or it comes if it is 75 meters or 250 millimeters, it comes under clogs or rough flakes. If it is less than 250 millimeters, your rock fragments is there comes under the stones or pebbles. So please note down these important things. And coming to the soil particles, yes, very simple, 0.2 to 2.2 mm is around the sand and gritty. If the condition is 0.02 to 0.2 mm, it is fine sand. It is also will be gritty in conditions. If you touch, if the soil particles is less than 0.002 to 0.02 mm, it's a silty powder. If it is less than 0.022, it is a clay fraction only. So these are the things, students. Please note down all these things now itself. After completing class, please note down. And these are the fragments. If it is 2 to 75 mm is the gravel pebbles. 75 to 250 it is comes under the clods and flags. If it is less than 250 it comes under the stones and boulders, which are big particles. So these are the rock fragments. Regarding with the rock fragment classification, and regarding the soil particles, these are the different fractions. These are the different classifications regarding the uh, regarding with the soil particles. And coming to the next slide, that's all for today. Thank you, students. Students, I know the class was we were not very comfortable. Climate was not fair. The climate was very hard. Still, it is raining here. That's why the climate is very hard to take the class. Anyhow, thank you, students. Thanks for the students who are present in the class. We have great patience. Maintain this patience and maintain this tempo of preparation up to the your JRF or SRF examinations. Then only you can achieve your target. Definitely, if you put minimum effort, you will get a very nice rank and everything. Don't worry, you'll get a very good marks, good ranks. You can achieve all those things. Anyhow, students, hardly okay, as I expected, there are only 5 members are there. Students, if you have any questions, please ask now. And I'm really sorry, climate was not very bad. That's why I'm unable to take the class very effectively. So next class, we will see. Next class onwards, we will deal about the pedology. So pedology is an interesting subject. We will deal all those things, and later we'll jump to the fertility, all those things. Any questions, students, please? If you have any questions, and do you want any mode of change in my class, etc., you can ask me now itself, because it's a very first class. Then I can maintain I can change myself, because I don't know, you are all from different areas, even different subjects. Anyway, yeah, any doubts, students? Please, any doubts or any questions?
Yes, sir. Sir, can I get
Yes.
any notes about this class?
Yeah, we will provide. This is only introduction now. We will give, don't worry. We will give, but don't depend don't expect that you will get notes immediately. So in the meanwhile, you should keep running notes also. You should
Yeah,
maintain
sir.
some.
Yes, sir. I can understand, sir.
Today I have, yeah, actually today I have give the today lecture is very elementary, very, I think it's just teaching an ABCD to the 10th class student. If you can compare like that. So all are very good students, all are coming from different universities. So anyhow, you should be very strong in fundamental, students, my view like that. Any questions, students? Any questions? Okay, students, I'm saying that today in the next class topic also, I'm going to take the class soil forming factors. So students, you please make yourself some preparation in background preparation, and I will take the class about the soil forming factors, all those things. Okay, students. Any questions, students, for today's class? Please, I'm seeing a new person, Abhishek. Abhishek, where are you from?
So I'm from Acharya Engineering Agriculture.
Oh, Acharanjiranga, you're from which campus?
I'm from HRL.
Medchal. Oh, nice. Thank you. Right. So, Miss Rai, are you okay?
Yes, sir.
ठीक है अब आज
Yes, sir.
क्लास
Yes, sir. Yes, sir. It's too good, but there were some issue due to network. It's no problem. All over, it was
I
too
can
good, sir. And
I
and
can
I think, sir, it's
yeah,
a
I
good
can
platform
understand.
for us. Yes, sir.
Yeah, because we have Niver. This Niver cyclone is there in my area.
Yeah, yeah, sir. Oh.
That's why still it is raining and cloudy condition. That's why the signals was very bad. That's why the
Yeah, yeah,
class
sir. I
was
can
not going.
understand.
But
All of our class was too good, sir. It's okay, sir. Next time.
okay. Anyway, thank you. Okay, students.
Yes, sir.
One general question. Everyone should answer. Students, you should answer. Are you ready?
Yes.
Okay. Do you know how these names were given to the cyclone? We have seen different
Cyclone.
cyclones. Yeah, for cyclones we are giving names like Petai, Gaja, Laila. We are given many names to cyclones. How these names are came and why these names are given to the cyclone? Any
Based
idea?
based on this impact.
No.
Yes, yes.
Different countries will give. It was a list already prepared by some meteorological organization or something.
Yeah. Actually, Abhishek is touched the point. It is right. Abhishek was giving right answer. Actually, our country before, if you see very olden days, I think around in, I think very early days only after 2009 or 8. I think I have not remember the exact year. Before those days, before giving those days, there many cyclones were came, especially in during 1980s, especially in Andhra Pradesh, in that Godavari Delta people are affected with immense cyclone. So no one don't knows
Yes.
when it came. So data was not available. So then after to go for the disaster management, for conducting the disaster management, some countries like India, Pakistan, China, and not China, yeah, China and Sri Lanka, Maldives, our neighbor countries like Vietnam and Singapore, all these countries, some few countries in some I think in some Middle East country, one country also was joined, and they are all joined. They came meeting and they prepared one list of names. So like that, that's why you can see some this Laila was named from Pakistan and the Gaja is from Sri Lanka. I want to check where this never came. So that this is the reason why we are
Yeah.
giving names to the cyclone to go for the disaster management and to want to calculate the impact. How much impact was there in the how much impact was created by that cyclone, this cyclone, only for the classification purpose. Why I'm telling all these things means students ICR was raising a bar. ICR day from year to year they're improving their standard. They were asking general questions. They're asking current affairs. So you should be very careful regarding this current affairs also.
Yes, sir.
Anyhow, students, one person had given right answer. Like this, you should be very thorough in current affairs. Make a habit of think about the soil, everything. Anyhow, make a habit of reading. Thank you very much, students, for your class, for your attention. Thank you very much. I'm sorry, today's class is somewhat very disturbing. Thank you very much, students. We can leave the channel.